Okay, so we're continuing with the quadratic functions that were in 3.1. Yesterday we talked about, just a quick review, we talked about basically the three different approaches. One is if it's in quadratic form, is where it would say f of x or y, because those are the same thing, equals ax squared plus bx plus c. So you would have an x squared and an x. And if you have that case, there are two things you can do with this. One being the negative b over 2a to find the h, or the x coordinate of your vertex, and then plug that back in to find y. So we're going to do an example of each of these. The second is to force it into standard by completing the square. And then you had, if it was already in standard, and for these you can find, for these obviously you don't need to change the format. You could find your vertex and all that stuff from it. So those were like kind of the three different kinds. All the things you're going to need to be able to identify from either would be the vertex, which is your HK, the axis of symmetry, which is your x equals h, your domain, which is what? All the time. All real numbers, negative infinity to positive infinity. The range, if it opens up, so it has a positive x squared, would be the k value to positive infinity, and if it opens down, it would be negative infinity to k. I don't know why I'm writing crooked, but it's happening. And then the max or min, if it opens up, it has a minimum, and that's the k value. If it opens down, it has a maximum, also the k value. Yep.
Zoom out for a second.
I'm not done yet, so wait. And then you can do your x-intercepts. For those, you're going to plug 0 in for y. And you can either solve this using factoring, if it's factorable. The even root, if it's in standard form, or quadratic formula. So you need to be prepared to use either of those, because sometimes the one works over the other. And then the y-intercept, and we plug 0 in for x in for x. Ideally, you do this in quadratic form because it will zero out your x squared and it will zero out your x, and it's just the c. And then we did, the last thing was the reverse, which is finding the equation. Given a point and the vertex. And for those, you plug them in to y equals a, x minus h squared plus k. You're going to solve for a and then plug back in. Plug back in not x and y, sorry, hk and a. So it was a lot of stuff, but that's basically everything that we did yesterday. So we're going to go to 8, and this is going to be find the vertex. So we're going to do the negative b over 2 method, negative b over 2a method on this one, because it doesn't say put it in standard form. So I have to do, the h is going to be negative b over 2a, and the quiz will tell you, find the vertex using negative b over 2a, and then there are two questions that will say put it in standard form. So you just got to follow what it says to do. So my a is 1, my b is negative 4, and my c is 3. Negative 4 over 2 times 1 is 4 over 2, which is 2. And that's the x coordinate of my vertex. And then I plug it back in to find the y. So y equals 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3, negative 4 plus 3, which is negative 1. That's the vertex. So then my axis symmetry is what? X equals 2, okay? And then the y-intercepts are the easy ones when it's in standard form like this. The y-intercept, I would just plug 0 in for the x. It would 0 these out, and I get 0, 3. And then the x-intercepts, I would see if this is factorable. Are there factors of positive 3 that sum to negative 4? Are there factors of positive 3 that sum to negative 4? Negative 1, negative 3. So I can actually factor this. If I couldn't factor it, then I have to use the quadratic formula from here. So I can factor this. 0 would equal x minus 3 and x minus 1. And then I'd split and solve, and I get x equals 3 and x equals 1. So 3, 0, and 1, 0. And then we graph. So I go 2, negative 1, and plot my vertex. My y-intercept is 0, 3. If I didn't, for some reason, have x-intercepts, then I could just reflect that over to get the third point, and that would be enough. The x-intercepts this time are 1 and 3. It didn't ask for it, but domain is all real numbers every time. Range, because it opens up, would be negative 1 to positive infinity. Yep.
How do you graph it again?
I plotted the vertex, which is 2, negative 1, right? I plotted that one. That's this point. And then I plotted the y-intercept, which was that one. And I said if there weren't x-intercepts, I could use the reflection of that point. So I went up 1, 2, 3, 4, and I went left 2. I could have gone to the right 2, and that would have been enough. But it also asked me for the x-intercepts, and there were x-intercepts this time, so I plotted those and just drew my graph through it.
Really all you have to do is just plot the y-intercept and then find what
You need the vertex. Obviously, you need the vertex, and then you need 2 other points. So you can plot any kind of point that you're given. You could plug in a point. You could use the intercept if you already have it, because there's going to be times in which there's no x-intercepts. If this was pointing down, there would be no x-intercepts. So I would have to use the y-intercept, and then I would reflect it over to get the other point.
In that form, will the last number always be the y-intercept?
If it's in quadratic form, yes. So if it's x squared and x, not in the parentheses squared, yes. Negative b over 2a. Nope. All right, so this one, negative b over 2a is the vertex, right? So negative b over 2a, I would get negative 8 over 2 times 2. Actually, this is going to be a Okay, this time it says put into standard form. So we're going to force this in to complete the square. Okay, this means complete the square. And you're going to have to do this twice on your quiz. And then once the negative b over 2a. And then once the find the equation. So I am going to group together the first 2 terms. Bump the negative 7 out. It just gets bumped out. We don't change the sign because it didn't go anywhere. It didn't go to the other side. If there was a number in front of the x squared, I would take it out. If there was a negative, I would take it out. If there's not, like it is, I just go to the second term, which is 4, ignoring the sign, divide it by 2 and square it. 2 squared would be 4, and I'm going to add that inside the parentheses and subtract it from outside the parentheses because it's all staying on one side. I have to balance it. If there was something on the front of the equal sign, or in front of the parentheses, I would multiply it times that negative 4 before I combine it with the negative 7. Now I've made it a perfect square, so I square root the first term, I square root the third term, I take the sign from the middle, put it in parentheses, and square it. And negative 7 minus 4 is negative 11. This is now in standard form. Then I find my vertex. So the vertex is the opposite of what follows x, which would be 2. and the whatever's after the parentheses, we keep the sign, so it's negative 11. From here, I can get my axis of symmetry, x equals 2. I know my domain, negative infinity to positive infinity. Which direction does this open? Up, which means I can get my range would be from k, negative 11, to positive infinity. And again, it didn't ask for it, but there would be a minimum here, and it would be negative 11. My x-intercept, I have to solve for x. I'm going to plug in 0. My y-intercept's the easy one to do. So my y-intercept, because it gave it to me in quadratic form, I would get it from there. This would be 0, 0, which means my y-intercept is 0, negative 7. The x-intercept is a little bit more work. So the x-intercept, you have two choices. Go back to the beginning and do the quadratic formula from here, or use your even root property from here. Make the y 0. I'd add the 11. I'd square root both sides, putting a plus and minus in front of the 11. And then I'd add the 2. So 2 plus and minus root 11, 0 would be my x-intercepts. So 2 minus root 11, 0, and 2 plus root 11, 0. I think there's one in here. Yeah, for sure. From here, if it didn't say graph it, right? But if I wanted to graph it, I would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, negative 11. I'd go 0, 3, 4, 5, 6, 7, negative 7 for my y-intercept. Now, those x-intercepts are hard to graph because that's a square root that you don't know. You can either estimate it. Root 11 is going to be in between root 9 and root 16. You could just say 3.5, 2 minus 3.5 and 2 plus 3.5. Or you already have your point from your y-intercept, just reflect it over. So from here, it's 2 to the right. So I'm going to go up 1, 2, 3, 4, and go 2 in the other direction, and then draw your graph. So as long as you have 3 points, that's enough information. You don't have to use your intercepts to graph it. No, well, yeah, but they won't. There's probably going to be a number on the front, so it's not going to happen. Yeah. All right, we changed this one. So we just made it so that 1, we're practicing with the number on the front. 2, we're practicing with the sign change on the one on the front. So we are going to put the equation into standard form. I'm going to do y equals, group together the negative 2x squared minus 5x minus 4. All right, now we got to do what? Take out the negative 2. So the negative 2 is going to come out. Y would equal negative 2 is going to go on the front, which means this gets divided by negative 2, and the negative 5x gets divided by negative 2. So I end up with a positive x squared, which is what I need, and a positive 5 halves x. Not yet. Nope, nothing happens with that negative 4 yet. Then I'm going to take that 5 halves, divide it by 2, which is the same thing as multiplying by half, and then square it. I'd get 5/4 squared, which is 25/16. I'm going to add that inside the parentheses. And I would normally subtract it from the 4 to balance out this side of the equation. But there's a number on the front, so I've got to multiply it by that number first. You with me? Okay. So that changes not only the sign but the fraction, right? Because it's a negative and a negative, this is going to become positive. 2 goes into 16 8 times. So I'm actually going to add 25/8. Joey.
Did we multiply 2 by negative 25 or 16?
Yep, so when you add inside the parentheses, you subtract outside the parentheses because you're balancing out that side of the equation. And then because you were subtracting it and you multiplied it by a negative 2, it changed it to positive. Okay, so now I can factor the left, or I can factor the parentheses. I would square root the first term, square root that second term, which would be back to when I just divided by 2. 5/4. Take the sign from the middle, which is positive, put it in the parentheses and square it. And then -4 plus 25/8, I have to give that -4 an 8 as a denominator. So it'd be -32/8 plus 25/8, which is -7/8. And there's the standard form of my equation.
What do we do with the 2?
Nothing right now. That 2 means it's narrow, and the negative means it's upside down. But we don't even need that yet. Everybody good so far? Okay, so what direction is this facing?
Down.
Down because of the -2, okay? What's the vertex? Good. -5/4, -7/8. So change the sign inside the parentheses, but leave the one outside. What's my axis of symmetry? Good. What's my y-intercept? Good. I would get that easiest by going back to the original and zeroing out all the x's and leaving with just the -4. So if you think about it, like obviously that was kind of hard to get into standard form, but if this question has 7 parts to it, we just got to the standard form, and then that easily gets you the vertex, the axis of symmetry. You should be able to throw in there the domain because you already know it. Like if you got your quiz and you wanted to write out all the domains, you go right ahead. Get yourself some points, okay? And then because this opens down, so I know my domain is -infinity to +infinity. My range, it opens down, so this time it's -infinity up to the k, which is -7/8. All of that before you even graph it. Summer. I plug 0 in to the standard form, so to the quadratic form up there. So when you plug 0 in, it's going to cancel everything but the c. It's way easier than obviously trying to plug it in to the standard form.
Then to find that x, can we go back to the original?
Yes, so x-intercept, you have 2 choices. Take this standard form and solve using your even root property, but that's pretty complicated. There's a bunch of fractions in there, okay? Or go back to the original and do the quadratic formula. So a is -2, b is -5, c is -4. So these are my x-intercepts. -5, so 5 plus and minus the square root of -5 squared minus 4 times a times c over 2 times a. And I get 5 plus and minus the square root of 25. This would be a +8. Well, here, let's do 16, +16 times -2, -32 over -4. And there's going to be a negative underneath my square root, which means there are no x-intercepts. If you had done the even root property, like I would have moved the 7/8 to the other side, it would have made it positive. I would have divided by a -2, it would have made it negative. And then I would have tried to square root it, and it'd still be square rooting a negative number, so it'd still be no x-intercepts. Sam?
Can't you just tell by your range?
Yeah, sure. You can also plot your vertex and look at your range. Yeah. All of that stuff should overlap. Like when you go to graph it, it should match up the information that you're getting for all the different parts. So it didn't say to graph it, but your quiz does say to graph it, so let's just graph it. My vertex is -5/4, so that's -1 1/4. So I would go -1 1/4, just past that, 1, and then -7/8. So it'd be like here. My y-intercept is -4. And then because I went down 1, 2, 3, and over to -4, I would go back to reflect that point. Draw your parabola, which is consistent with not having any x-intercepts.
plot a vertex, it's like a action.
Yeah, you're going to need to. Yep, 100%.
It's definitely accurate as long as like.
Right. I mean, you're going to get a line that says vertex, and on that, it should have that point. So, yep. The other thing is, should you finish with some extra time, you could plot as many points as you wanted in here to make sure it's going the right way. Like, I could plug in -1 and make sure it's going the right way. I could plug in -2, make sure it's going the right way. But you'd have to have the extra time to do that. So this is my x, and this is my y, and this is my h, and this is my k. Y equals ax minus h squared plus k. So -4 equals, a is our unknown. X is 3 minus a -3, because that's the h, so this is plus 3 squared, plus the k, which is 4. -4 equals a times 6 squared plus 4. Subtract that 4. Divide by 36. 4 goes into both those, right? 2/9. So that's your a, and then you plug back in the a and the h and the k. Y equals -2/9 x plus 3 squared plus 4. So there is 2, complete the squares, graph, find all the missing pieces, right? There is 1 -b over 2a, find all the things. And there is 1, here's your point and your vertex, give me the equation.
How long will we have?
Like probably 30 minutes, maybe even a little bit more. Yep. Did we do this one yesterday? No, right? Okay, so go to 16. We did 16? Okay, so 3, 2 is polynomial functions of higher degree. So these go beyond an x squared. This could be an x squared, but it could also be an x to the 3rd, x to the 4th, x to the 5th, x to the 6th, okay? So we're going to learn that when you look at an equation, there's certain things that you can find just by looking at the equation that would determine the overall shape of your graph. The first is the end behavior. And the end behavior means what are the arrows doing at the ends of my graph? What's the arrow on the left doing? What's the arrow on the right doing? Okay? All of these will have arrows in both directions. So it's not like it's piecewise. They're not going to stop. These will always have arrows in both directions. So there's no square root functions or anything like that. If your highest exponent, so it says the odd degree, the degree is the highest exponent. Doesn't have to be first. Doesn't have to be last. Anywhere in my equation, it's the highest exponent. If that number is odd, then the ends have opposite behavior. One goes up and one goes down. If it's odd and the number in front of it, which is the a, so let's just say it says ax to the n, okay? And n in this case is odd. If it is odd exponent and the number on front is positive, then the graph falls to the left and rises to the right. So if it is a positive x to the 5th, let's say, it's going to fall to the left and rise to the right. We don't know yet what's happening in between, but we know the arrows at the end are doing that. If the a is negative, then the graph rises to the left and falls to the right. So if it is a negative x to the 5th, it's going to rise to the left and fall to the right. Again, it can go up and down in between. This is just the end behavior. So think like an x to the 3rd, right? An x to the 3rd goes up to the right and down to the left. That's consistent with what we're talking about. It's got an odd exponent. If it's positive, it goes up to the right, down to the left. If it was negative, it would reverse. If the degree of the polynomial is even, then they have the same behavior, which should make sense for like a parabola, right? X squareds, they either both go up or they both go down. If the a is positive, so if it's a positive x to an even power, like a positive x squared, then they both go up. And if it's a negative x with an even power, like a negative x to the 2nd, then they both point down. Same would be true for x to the 4th, x to the 6th, x to the 8th, anything even. This sometimes is called the leading coefficient test. If you see that, coefficient test, okay? And it'll say like use the leading coefficient test to determine the end behavior. That's what it means. So looking for the highest exponent, if it's even and positive, they both go up. Even and negative, they both go down. If it's odd and positive, rises right, falls left. If it's odd and negative, rises left, falls right. Okay, zeros and multiplicity. So the zeros of a function are the same thing as the roots, the solutions, or the x-intercepts if they're a real number. If it's I, obviously it's not going to be on your graph. So for these, we're going to set our function equal to 0 and solve it. You might have to factor it. There's a lot of factoring, okay? You could use the quadratic only if it was x squared. So most of these will be factorable. And then the multiplicity is how often a root occurs. So if you get the same answer more than once, it now matters. Before you would just list it, right? Like if I had the same answer twice, I would say you only need to list it once. But the fact that it's happening twice matters because it causes the graph to change direction. If an answer occurs an even amount of times, then it hits the x-axis and turns at that point or bounces off the axis. If it occurs an odd number of times, then it crosses through the axis. So if I had x equals 2 and x equals, let's say, -1, and that happens twice, then I would have a -1, a +2. My end behavior could be whatever it is. Let's say it goes up to the left. If it hits that -1 and that happened twice, it's going to bounce off it. It's going to come back down. And because 2 only happens once, it would cross through it. So an even number of times it's going to bounce. An odd number of times it's going to cross through. Okay, so we're just going to do this one, then we're going to stop. The end behavior, the zeros, and the multiplicity. So first of all, look at my function. Is it in decreasing degree order? Is it in highest exponent down to none? Yes. So what's the degree of this function? 3, which is even or odd? Odd, which means one's going up, one's going down. Go to the front of that term. Is it positive or negative? Positive. So it's positive and odd, which means falls left, rises right. So already I know my arrows would go that way and that way. If this was multiple choice, you could probably narrow down 3 graphs. Now I want to find my zeros. So I'm going to make f of x 0. How do I factor when there's 4 terms? Group it. So I would take out an x squared, take out a -4, I get x plus 2 and x squared minus 4. Am I done factoring? No, because that x squared minus 4 is
X plus 2x minus.
good. So I solve each of these and I get -2, -2 again, and +2. Good. So it's going to bounce at -2. So when you write it, like in homework or on the PDF or whatever, I literally just put a little 2 next to it to remind myself that there are 2 of them. And then I would write 2. It's going to bounce off of -2. It's going to cross through at +2. If it occurs an even amount of times. So if there's 2 of the same or 4 of the same, it's going to bounce at that point. If it's an odd number of times, so it only happens once, it happens 3 times, it's going to cross through that point. So we're going to do more of this tomorrow. Like we'll start graphing a little bit more. We'll do the y-intercept, which is good practice for your parabolas. Like there's some overlap here, okay? And I don't want to get too far into it. This is just going to get us started into 3-2.